Assalamualaikum everyone. I'm Muhammad Wahid Al Islam. Now I am going to discuss about the numbers and cryptography, the mathematical expansion behind RSA. I will focus on how idea was developed and why it is important in cryptography. This work is part done under course instructor of Dr. Arif Muhammad, Professor, Department of Electrical and Electronic Engineering, University of Chidawat. In this scheme, we can see three persons, Andy, Sam, and Eve. Suppose Andy and Sam are friends. They want to communicate over internet connection. Here, Eve is an attacker. He can interrupt the message during transmission. For example, Andy sent a message, "Hey Sam, how are you?" But Eve can read and modify it, changing into, "Hey Sam, lend me $100 please." So this shows that communication over open network is not secure. We need encryption to protect the message from attacker. Before going to the problem, let me briefly explain some basic concepts of cryptography. First question is, what is cryptography? Cryptography is the technique of securing communication so that only the intent receiver can understand the message. Why do you need cryptography? We need cryptography to protect data from unauthorized access, to maintain privacy, and to ensure secure communication over the internet. Here we can see that sender and receiver. Sender wants to communicate with receiver. Here plaintext is readable message from sender. Encryption: the algorithm and key convert plaintext into ciphertext. Ciphertext: unreadable data transmitted over the network. Decryption: the algorithm and key recover the original message. Here plaintext: original message received by the intended receiver. So encryption: convert plaintext to ciphertext. Decryption: convert ciphertext to plaintext. Here, keys play an important role for encryption and decryption. Cryptography basically two types: symmetric cryptography and asymmetric cryptography. Symmetric cryptography encryption using a key. Same key is also used by decryption algorithm. Asymmetric cryptography when encryption algorithm and decryption algorithm use different keys. In the early stage of cryptography, symmetric cryptography is used. Problem with symmetric encryption. In traditional cryptography or symmetric encryption, the same key is used for both encryption and decryption. This creates a major problem. Two users must already share a secret key, or they must depend on a key distribution center. Problem is, if the key is exposed, communication is no longer secure. If KDC is compromised, entire system is broken. Whitfield Diffie argued that relying on a central authority like KDC is risky. He questioned what is the use of strong encryption if the key itself is not secure. Second problem is digital signature. Another issue: how to prove who sent a message. Later, this leads to the concept of digital signature. Here, Diffie-Hellman key exchange or color mixing magic. Whitfield Diffie and Martin Hellman in 1976 were trying to solve two major problems in traditional cryptography: the difficulty of security sharing secret key and need for reliable digital signature. They realized that relying on a shared secret or central authority like Key Distribution Center or KDC weakens security. So they proposed a new approach. where secure communication could occur without exchange secret key in advance. The key idea was to use two different but mathematically related keys on public and on private, so that anyone could encrypt a message, but only the intended receiver could decrypt it. This breakthrough led to the concept of public key cryptography, forming the foundation of modern secure communication system. They explain secure key exchange using a simple color mixing. In the right figure, we can see two persons, Alice and Bob. Suppose they are friends. Both people agree on a common color, for example yellow. This yellow color is public, so everyone can see it. Then they chose a secret color. Alice chose a red, Bob chose a blue color. Then they mix secret color with public color. Alice mixed yellow and red, create a new color. Bob mixed yellow and blue, create new color. They can exchange the mixed color over the public transport. After receiving mixed color, each person mixes with secret color. Surprisingly, both of them get the same final color, which becomes their shared secret. Even if an attacker see all exchange color, it is very difficult to find the original secret color. This is the basic idea behind Diffie-Hellman key exchange. Secure key sharing without directly sending the secret. After Whitefield Diffie, after Whitfield Diffie and Martin Hellman introduced public key cryptography in 1976, the main challenges become how to design a practical system based on OA function. To solve this problem, Ron Rivest, Eddie Shamir, and Leonard Adleman focused on finding a function that is easy to compute but extremely difficult to reverse, which is the core idea behind secure cryptographic systems like RSA. Actually, Ron Rivest, Eddie Shamir, and Leonard Adleman wanted to find a function that is easy to compute, very hard to reverse on a function. Here is an example. Input x and function fx easy to compute. Output y equals to function of x, but very hard to find x from y. They wanted function f such that given x compute y equals to function of x is easy. Given y, finding x is very hard. This is on a function. Many failed. They tried different ideas like knapsack problem, permutation polynomial. Also, they explored abstract algebra and number theory. Abstract algebra basically studies mathematical structure like graphs and rings, which are used to design and realize cryptographic systems. Number theory deals with properties of number, especially prime numbers. It is the most important foundation of RSA. Knapsack problem is a mathematical puzzle where we try to select numbers that add up a target value. It was used in early cryptography but later found to be insecure. Permutation polynomials are a special function that arranges numbers in a unique way. They were studied for creating secure transmission in encryption, but they were not secure or did not satisfy all requirements. At one point, they even thought this might be impossible. Basically, reverse design algorithm, Shamir designed mathematical operation, Adleman find their weakness. Rivers started thinking about the number theory, especially modular arithmetic exponential. Then came the key idea, exponential easy to compute, but combined with hidden structure like prime number. Mathematical inspiration. Multiplying two large numbers is easy. Here we can see P and Q is a prime number. N is the product of multiply both P and Q. But multiplying is easy to compute. But reverse it factorizing is very hard. Given n equals to something, find p and q. It is impossible, almost impossible. This is based on the integer factorization problem, believed to very hard for large number. This is different and difficulty is the foundation of RSA security. Rivest spent a whole night refining the idea and developed a system where public key use modular exponential. Suppose C is the ciphertext, M is the message, E is the public exponential. Public key N, E is published and can be shared with anyone. Here N is public but P and Q are secret. Then private key depends on secret prime factor. Private key here D can compute only if you know P and Q. Adleman then verified the mathematics with modular arithmetic and Euler's theorem. Mathematical verified the system proven to work. Final result RSA algorithm to find outcome. A practical public key crypto system is called RSA algorithm. Using a public key and message is transferred through internet and decryption using a private key. So if you have private key, you can open the lock. That means you can read the original message. Thank you for your attention.